Dr. Babasaheb Ambedkar Open University.
Dear students and learner of this course, I Kamesh Rawal welcomes you to the Dr. Babasaheb Ambedkar Open University. Let us start our today's discussion. In the last session, we have focused on what is actually computer, why we have invented the computer, right? So we have seen that thing, that the computer is actually invented to do a compute, right? Computation, right? Calculation. So during the invention of the computer, we people, humans, are actually thinking we are inventing, or we want to invent a machine which can do any arithmetic operation like addition, subtraction, multiplication in a very fast period of time, right? So to do this process faster, we have actually invented the machine. But now, you know, there are so many things, so many activities which we are doing with the computer in which there is no computation is involved, right? So, you know, afterwards we have defined a definition of the computer, that computer is nothing. Today's computer is a data processor which takes the data as an input, it processes it and produces the output. Fine. Now in the same way, right, we are just continuing and we will see few more things about the computer. In the today's session, we are just focusing on how the first generation of the computer is actually how it is invented, right? What changes they have done, and they have built a second generation computer. What changes in the hardware technology that is done to make the third generation, and so on, right? So here we are talking about a different generations of the computer, right? The term generation, it is actually, you know, where the major changes is done into the technology, right? There is no clear cut boundaries there, right? Let's suppose that if we'll talk about our DDR RAM. So obviously, you know, suppose if you are taking a few years older machine, in that DDR2 RAM was there, then DDR3 came. So obviously when some technology gets changed, something gets changed into the computer, it doesn't mean the whole computer's generation get changed, right? But when the major changes is done, then we can say yes, this was the older technology, right? This was the older generation and this is the thing from a new generation. So there is no clear cut boundaries there, but here we are just you know, distinguishing two generations with the help of hardware technologies, right? Okay, so this is something about, you know, the first generation computer. So it's okay that, you know, first computer was abacus, later on the Pascal has designed a Pascaline machine, right? And afterwards, right, George Boole has done some work, right? Few gates are actually invented, and afterwards, after using all these things, you know, we have made a first generation. Okay, now what was there in the first generation computer? So the first generation computer, right, the name of the first generation computer was a ENIAC. So see here, ENIAC. ENIAC was what? It is the name of the first generation computer. ENIAC, which stands for Electronic Numerical Integrator Calculator, right? So, you know, initially the first machine whatever we have made, it was not actually the computer, it was a calculator, right? So ENIAC, it was the first machine, and these two scientists, right, Eckert and Mauchly, these two scientists has developed this first generation computer ENIAC in 1946, right? So you should know the first computer we have made, right, in 1946. And what was the name of that machine? It was ENIAC, Electronic Numerical and Integrated Calculator. It was actually developed in the USA, right? Now here, to build this type of machine, you know, there are 20,000 vacuum tubes. Now, if you have a little bit idea of the physics, then vacuum tubes are what? They are actually a filament which is made by a glass, right? So, glass made filaments are there, and in the physics we call that vacuum tubes as a diode, triode, tetrode, pentode and so on. This type of filament, one filament is actually using this much space, right? And it is actually a filament made by a glass. Using 20,000 vacuum tubes, the first generation machine ENIAC was created, right? And ENIAC was made. Okay, so here 20,000 vacuum tubes were there, right? That they are actually assembled into a one machine. Now you just think, if one vacuum tube occupy this much size and 20,000 vacuum tubes, if you are embedding into a one computer, you just think of the size, right? So the first generation computer was a very large in a size, right? It was occupying the whole space of the room, right? So the thing ENIAC, it was actually a first computer which is made by more than 20,000 vacuum tubes, right? It was actually, the weight of this machine is more than 30 tons, right? And this much 150 kilowatt energy was actually required to run this particular machine. So see here, basically the machine was using which technology? Vacuum tube technology. So suppose if anybody is asking you what technology was used in the first generation of the computer, so you should know, in the first generation of the computer, vacuum tube technology has been used. How many vacuum tubes has been used? More than 20,000, right? And the weight of the machine was more than 30 tons, and it was using 150 kilowatt of energy, right? Now, what was the speed of that machine? The speed of that machine, it could perform somewhere around 5,000 simple addition. Let's suppose if we'll talk about addition, then 5,000 simple addition, and somewhere around 385 multiplication in a 1 second. So this was actually the speed of this machine, right? 5,000 addition, and suppose if you don't want to do the addition, but if you want to do the multiplication, then you can multiply 385 numbers in a 1 second. That was actually the speed of the first generation machine ENIAC. In fact, if we'll talk about today's machine, our today's machine are more powerful than this particular first generation machine, right? Okay, now because of the machine ENIAC was made by using more than 20,000 vacuum tubes. So due to that reason, it was occupying huge space, right? So room size of space that has to be reserved for this particular machine, right? Okay, the cost, obviously the huge giant machine, right? Obviously it was costing somewhere around $487,000 at that time, and if you convert that amount, then it is somewhere around, we can say, okay, so here I have written the today's amount. Okay, fine. After the first generation, now see, there are a lot of problems were there in the first generation machine, right? It was a huge machine, right? Weight was huge, large amount of electricity. It was a very costly machine. So due to that reason, right, a second generation computer was made. And what we have done in the second generation computer, so all the vacuum tubes, right, what was actually the technology is being used in the first generation computer? It was a vacuum tubes, and because of the vacuum tubes, there are so many problem occurs, right? The machine needs a huge amount of space. It was occupying large amount of electricity. It was very costly to build, and there are so many other problems are there, right? Due to that reason, in the second generation computer, those vacuum tubes are actually replaced by a transistor. So here, in the photograph I have shown, these are the transistor. The transistors are actually a small semiconductor made by a semiconductor material. So this is a transistor made by a semiconductor material, right? Usually it is a silicon and germanium. So these metals are actually, they are very cheaper, and work of a one vacuum tube we can replace with a one transistor, right? તો એક વેક્યુમ ટ્યુબનું જે કામ છે એ કામ આપણે એક જેને કહેવાય ટ્રાન્ઝિસ્ટરથી રિપ્લેસ કરી શકીએ. બટ લેટ સપોઝ વિલ ટોક અબાઉટ અ વેક્યુમ ટ્યુબ. ઇટ વોઝ ઇટ ઇઝ ઓક્યુપાઇંગ huge amount of space, and these are very small, these are very tiny device, right? So what we have done is the major shift, the major change which we have done from first generation computer to the second generation computer, we have replaced all the vacuum tubes with a transistors, right? The first benefit of the transistors are actually a smaller device, so obviously the size will become smaller, right? The size of the first generation gets reduced. Second thing, this actually works with a very small amount of electricity, so obviously the overall electricity consumption gets reduced. Fine. Third thing, to make this transistor, what we are using is we are using silicon or germanium type of semiconductor material, and these materials are very cheaper, right? And due to that reason the cost has been reduced. Fine. So in the second generation, the main thing that we have done, that is we have used a transistor technology, right? We have replaced vacuum tubes technology with the transistor technology. So in the second generation computer, transistor was actually fitted into the computer, right? And lot of benefits that we have served by this second generation of computer, right? So basically the second generation computer in which the transistors are being used, they are actually made in 1959. The main component, right, the technology which was actually used in the second generation computer was transistor, right? Now see, transistors are actually made from a germanium kind of semiconductor material, right? So it is a cheaper, it is more reliable than the vacuum tubes. Because of the vacuum tubes, two other problems were there, right? Vacuum tubes produces a lot of heat, so to cool down the machine we need to put that ENIAC into a properly air conditioned room. But instead of that vacuum tube, when we have replaced this transistor, at that time transistor is not actually producing that much heat, right? So this is what it is, a highly reliable. Second thing, because of the heat, most of the time the ENIAC was, you can find the ENIAC every time into the maintenance mode. Why? Because this time one filament get burns, if we are replacing it another filament get burns, so that type of problem was there, right? But now instead of vacuum tube, when we have replaced all the vacuum tubes with the transistor, we get a more reliable machine, right? So reliability get increased, electricity consumption will be reduced, cost will be reduced, and we got a faster machine. Okay. Transistor mode switching operations are 10 times faster than the vacuum tube. So obviously because the transistors are 10 times faster than the vacuum tube, so the second generation computers are obviously 10 times faster than a first generation machine. Transistor were a very small in a size, right? So it is a 1/10 of the first generation's vacuum tube, right? That consumes a less electricity. Fine. And it is 10 times cheaper than the first generation computer, right? Magnetic core memories, I think if you have heard in a earlier computer, we people have used floppy disk, right? So that type of floppy disk, even today we are using a magnetic memory, right? And that is nothing but it's a hard disk. So hard disk, we can say floppy disk, such type of magnetic core memories are actually being developed during this particular era. Fine. some languages also have been developed, and those languages are high level languages, right? With the ENIAC, we were done or write the code into the assembly or machine level language. But when the second generation computers came, at that time several high level languages like Fortran, formula translation, or COBOL, common business oriented language, are developed. So this is something about a second generation computer, right? So in 1946, the first generation computer ENIAC was invented. What was the main technology used in the ENIAC? It was a vacuum tube. In the second generation, in 1959, second generation computer is invented, and in that, what major shift that we have done? So instead of vacuum tubes, we have used a transistor, which actually made from a germanium material. Okay. Then in the third generation computer, in the second generation computer, basically, the repairers of the machine are actually facing the problem. What problem was faced by that engineers? This transistors are, it's a very small device, right? So transistors are basically a very small device, and to solder this type of small device on the motherboard, it was actually a challenging task, right? So that problem is actually overcome, and in the third generation we comes up with a IC technology, right? So here in the third generation, all the transistors, right, are actually replaced the vacuum tubes, right? In the second generation, all the transistor has replaced the vacuum tubes, and in the third generation, IC, that is called integrated circuit, is being invented. Now what is actually integrated circuit? So I think in the next slide I have placed a photograph, right? It was actually a small silicon wafer, right? Instead of that germanium, now we have used a silicon material, and from the silicon we have made a small wafer. And what we have done is, we have tried to place this small transistors on that small wafer, right? And that wafer, right, which contains several transistors, right, which are actually soldered. So that is called integrated circuits. So basically, in the first generation we have used a vacuum tube, and the second generation we have used a transistor, and the third generation we have invented IC technology. It is called integrated circuit. Now what is integrated circuit? It is made from silicon material. It is a thin layer, it is a wafer, and on that wafer we have placed so many small transistor. Fine. So third generation computer, started from 1965. Okay, and instead of using a germanium transistor, we have started to use a silicon transistor and one silicon wafer, right? This silicon transistors are, it is much smaller than the germanium transistors, right? And we can successfully place few hundreds of, this transistor on a small thin layer of, again, silicon, right? And this wafer is called integrated circuits. It is called IC. Okay, so the main thing that is actually we have placed in the third generation computer, it was IC, right? So suppose if anybody is asking you, what is the technology we have used in the third generation of computer? So in the third generation of computer, we have used IC, integrated circuit. In that, IC is somewhat a small thin layer of the silicon material, and in which we have placed few hundreds of transistors, right? Because of ICs, the third generation computer becomes much more smaller, right? So let's suppose if we'll talk about first generation to second generation to third generation, the size of the computer get reduced, the electricity consumption was reduced, the speed has been increased, right? And lot of more we can say. Let's suppose if we'll talk about a first generation computer, it was slower, right? Second generation computer, it was more faster than the first generation, and third generation it becomes more faster. So when we are changing the generation from first generation to second generation to third generation, obviously the speed that is again increased. Fine. This is what the photograph, right? So here I have shown, this is what here small thin wafer is there. This wafer, the material of this wafer is, it is it is not germanium, it is a silicon. So one silicon wafer is there, and in which this type of circuit diagram we have made, right? And these are small squares. They are actually representing what? One transistor, and this is the whole circuit that you can put it here in this particular block. And in that way many blocks, right, many blocks are there, in that you can put a separate circuitry. So this is what the photograph of the IC. I think let's suppose if you are opening any electronic device, right, then you will get this type of thing which is actually shouldered on the board, right? And this is nothing, it is called IC, it is called integrated circuit. Now what we have kept inside this IC, it is nothing but the various transistor. So here in the third generation computer, we have made a small thin wafer from the silicon, and in that we have successfully placed a small electronic component like transistors, capacitors, etc., etc. Fine. What happened in the fourth generation? So when we will talk about a fourth generation, we are talking about this era, right, 1971 to 1985. Okay, during this period, the fourth generation computer we have made, right? So fourth generation computer came in somewhere around 1971 to 1985. Now in this computer, what we have done is the same technology we have used, that was IC technology, but slowly and gradually we get success to put more and more component, right, more and more electronic component on a small chip, right? So initially we have get success to place several hundred electronic component on a one chip, right? Later on we have placed few thousand of components. So slowly and gradually, the large scale integration circuits where we have placed few hundred of electronic components on the silicon wafer, very large scale integrated circuit, it is called Well-C technology. See, ultimately Well-C technology is nothing, it is based on ICs, right? But this is a very large scale integration, means what? A huge amount of more than 50,000 component, electronic component we have successfully placed in a one silicon wafer, right? Later on, after this, ultra large scale integration circuit will comes, right? And in that few millions of component that we have placed on a small silicon wafer, right? So basically in the fourth generation, the same technology we have used, but we have tried to place a more and more small electronic component on the chip, right? During the fourth generation computer, the term came which is called a microprocessor, right? So here the term microprocessor, the computer whatever we are using today, right, it is a microcomputer, right? Suppose if you are using a laptop, then it is nothing but it's a microcomputer. So here they have invented a small chip, right, one small chip, one small IC, and millions of small electronic components they have placed on it. And now this chip is known as your processor or your microprocessor, or you are sometime calling this particular chip as a CPU, right? CPU, central processing unit, or microprocessor, everything is same, right? So here what you have is, you have small IC, and on that there are several components, whatever is required to make a CPU, that we have placed on a single chip. Fine. So here during the fourth generation, microprocessor has been invented, right? Then the another memory that is called disk memory, like a floppy disk, hard disk, right? That type of memory is invented, right? Basically initially in the third generation magnetic memory was actually hard disk, but now in the fourth generation, along with hard disk, another movable portable drives are invented. They are nothing but the floppy. Okay, what major thing we have achieved in the fourth generation? So the computer becomes much more faster and reliable, right? Okay, then the new term has been started. It is nothing, it is called PC, right? We have called this microcomputer machines as a personal computer, PC. In the today's session, mainly we have focused on different generation, right? We have seen first generation was actually a very large machine, very costly machine, and it was using vacuum tube technology. In the second generation, we have made a faster machine, right, which takes a small amount of space. It was not that much costly machine, right? The speed that gets increased, it was using less electricity by replacing the transistor, by replacing the vacuum tubes into the transistor. In the third generation, we have seen there are IC technology, right, is invented, and due to that reason in the third and fourth generation computer we are getting more powerful machine, more reliable machine compared to first and second generation. Fine. So in the today's session we are just keeping our discussion up to here. We'll meet in the next session and we'll discuss few more topics. Till then, take care and bye bye.